Boom. All right. Now, no, I don't think the double angle formula is part of the formula sheet. It may or may not be. I can't remember at this precise moment. But whether or not that is the case, you have to be able to derive the double angle formula using the compound angle formula. So in other words, you're using this guy, the formula for sine of A plus B, to derive the formula for sine 2A. All right? So using sine of A plus B, you say your first line would be to let B equal A. So in other words, you're saying instead of sine A plus B, you're now looking to find sine of A plus A. So in other words, you express 2A as A plus A. All right? So therefore, sine of A plus A. So in other words, you're finding the sine of the sum of two angles where the both angles are equal to each other. All right? So sine of A plus A. If B is equal to A, then it will get sine of A plus A. This, of course, you will recognize as sine. Well, A plus A is the same thing as 2A. All right? So all we do is substitute for B over here. So in the same way that we substituted B here, we do the same thing here. So wherever we would have had B here, we now replace it with A, because B is equal to A. So sine of A plus A would now be equal to the sine of A by the cosine of A plus the cosine of A by the sine of A. This B now becomes a and this B now becomes A. Remember, of course, that sine A cos A is the same thing as cosine A sine A, because multiplication is commutative. 2 by 3 is the same thing as 3 by 2. So this, of course, will be the same thing as sine A cosine A plus sine A cosine A, which is the same thing as 2 sine A cos A. All right? So the first double angle formula, and we tuck it up in the corner here, is 1. That sine 2A is equal to 2 sine A cosine A. All right? Nice. So the same procedure that we would have employed to find the sine of 2A using the compound angle formula, we will do the same thing for cosine of 2A. So just as we did here, we're going to start off with cos of A plus B. And then we let B equal to A, and we proceed. Yeah? So we rub off this now. Check it out. Screenshot, take your notes, and we're going. Right? So instead of sine A plus B, we now start off with cosine of A plus B. We know that the cosine of A plus B is equal to cos A cos B minus sine A sine B. All right? So just as we did in the case of sine of A plus B, we say let B equal to A. And that will give us now that cosine of A plus A, which is the same thing as cosine of 2A, we substitute A for B, so it will give us cosine A minus sine of A by sine of A. All right? Cosine A by cosine A, of course, is cos squared A, and sine of A by sine of A, of course, is sine squared A. So therefore, we can say that the cosine of 2a is equal to cos squared a minus sine squared a. All right. So we could put that as identity 2. Cos 2a is equal to cos squared a minus sine squared a. Not to be confused with cos squared a plus sine squared a, which we know is equal to 1. The irony, however, is that we're going to use cos squared a plus sine squared a to derive 2 further versions of cos 2a. All right? So watch carefully. We know that cos squared a plus sine squared a is equal to 1. Right? Now, we have cos squared a minus sine squared a here. So what we have here is cos 2a in terms of cos squared a and sine squared a. We can, however, express cos 2a in terms of cos squared a alone, and we can express cos 2a in terms of sine squared a alone. How do we do that? We go back to our good friend here. From this equation, we make cos squared a the subject of the formula, and we can say that cos squared a is equal to 1 minus sine squared a. And if we make sine squared a the subject of the formula, we can say also that sine squared a is equal to 1 minus cos squared a. All right? Now, these two you must have at the tips of your fingers. Right? You wouldn't see this on any formula sheet, but it is expected that you should be able to call upon these two as derivatives of cos squared a plus sine squared a is equal to 1. So in other words, we would have derived cos squared a plus sine squared a. You need to be able to derive this. And as part of using this, you have to be able to know that if you make cos squared a the subject of the formula, you'll simply get 1 minus sine squared a. And if you make sine squared a the subject of the formula, you'll simply get 1 minus cos squared a. Now I'm going to bring the thing out a little further now. Cos squared a is equal to 1 minus sine squared a, which, if you employ the difference of 2 squares, you'll get 1 minus sine a into 1 plus sine a. And by the same token, you could express 1 minus cos squared a as 1 minus cosine a into 1 plus cosine a. Again, you wouldn't see this on any formula sheet, right? But this is add maths. This is not maths, right? So by the time you reach here, all of these things are taken for granted. They're not expecting to have to explain to you that if you see 1 minus sine squared a, you could invoke the difference of 2 squares and express that as 1 minus sine a into 1 plus sine a. Likewise, they're not expecting that if you see 1 minus cosine squared a, that they would have to explain to you that you could invoke the difference of 2 squares and write 1 minus cosine squared a as 1 minus cosine a into 1 plus cosine a. They're not expecting to have to explain that. All right? So, all of this, you'll find a lot of questions where you had to use this, you had to use this, and you had to use this and this. Boom. Take it, run with it, and use it in some questions to practice. All right? So, we're going back to our good friend here now. If we want to express cos 2a in terms of cos a alone, what we do, is that we substitute for sine squared a in this equation. All right? So we say then that the cosine of 2a is equal to cos squared a minus, brackets, 1 minus cos squared A. All right? So here now is where I will erase these things here. All right? Again, in fact, hold on. Take this out. And right. So we step away from the board. You have the opportunity to take a screenshot. You could pause the video and take some notes. We're going to rub off this section in green and continue with the process of deriving two alternative forms for cos of 2a. All right? So, we go in again. We want to express cosine of 2a in terms of cos squared a. Cos a, in terms of cos squared a, in terms of cos a, right? We want to express cosine of 2a in terms of cosine a. We substitute for sine squared a. We know that sine squared a is 1 minus cos squared a. So this will be cos squared a minus 1 minus cos squared a. We multiply out, you'll get cos squared a minus 1 plus cos squared a. Looking like a hybrid between an a and an h, which will give us cos squared a plus cos squared a will give us 2 cos squared a minus 1. All right? And if you want to be absolutely facetious, we could express this 2 as a difference of two squares utilizing surds. We could say, for the sake of argument, that 2 cos squared a minus 1 is the, let me just make sure the signal come in. Yes? Right. We can say that 2 cos squared a minus 1 is the same thing as root 2 cos a minus 1 into root 2 cos a plus 1. Y'all didn't see that, eh? Yeah. Now, it is highly doubtful that you will be called upon to do that in an exam at this level, but I just showing you how the thing does go. We extend the thing, we expand the mind. All right? Right. So we have our, let me say this is 2. Let me say this is 2. Let me call it 2a. Right? Yeah, let me say 2a. And let me say 2b. 2b, right? Cos 2a is equal to 2 cos squared a is equal to 2 cos squared a minus 1. Of course, we could express this 2 as a difference of two squares by treating the square root of 2 as root 2, and we just use. So in other words, even though 2 is not a perfect square, we use surds and we express root of 2 as just root of 2. Right? So, let us now do the same thing on the other side, where instead of expressing it in terms of cosine alone, we want to express it in terms of sine alone. So in other words, you could get a question that says, derive an expression for cosine of 2a or cosine of 2x, expressing your answer in terms of sine a or sine x only. So in other words, you go through the regular procedure, you reach here. And if you want to express it in terms of sine a alone, it means that you substitute for cos squared a using the first Pythagorean identity as follows. All right? So we could say then that cos 2a is equal to cos squared a minus sine squared a, which is the same thing as 1 minus sine squared a in brackets minus sine squared a, which is the same thing as, we move the brackets now, you get 1 minus sine squared a minus sine squared a, and you get 1 minus 2 sine squared a. All right? And just as we did before, we could express, make it a little more A-ish now. All right? We could express this as a difference of 2 squares by saying that this is equal to 1 minus root 2 sine A into 1 plus root 2 sine A. All right? So in other words, in considering the use of the difference of 2 squares, we don't have to limit ourselves only to perfect squares. We can employ the idea, even with numbers that are not perfect squares, once we are prepared to recognize that the square root of a number that is not a perfect square would be an irrational number, which we could write in a nice shorthand form using the third technique. All right? So the third form of cosine 2a then would be that cosine of 2a is equal to 1 minus 2 sine squared a. All right? So you have to be able to derive these things. All right? And in the course of this video, it is my hope that by seeing the process, you understand that you don't have to cram these things necessarily. Once you understand the steps, maybe you could just memorize the steps, go through the working a few times, all right, do enough past paper questions so that you would encounter that kind of question a few times, and each time you encounter it, you'd make sure and do it over so that you could practice via repetition. All right, so we had sine 2a, we had cosine 2a. We now going to do the same thing for our good friend tan of 2a. So of course, the first step that we take is to erase the board. All right, again, we step away from the board, take your notes, and we proceed. All right? Let me go with the tan of 2a now. Yes, Papa, that's the fall, that's the fall. All right, so we're going again. So, let me make the thing a little more uniform now. That's 2. This is 1. All right, let me make the thing properly. 1 in brackets. We come in with the 3 just now. So 3 tan 2a is equal to, let me fix that now. So the tan of a plus b, all right, tan of a plus b is equal to 1. Let me just make sure. Tan a plus tan b. All right. So tan a plus b is tan a plus tan b over 1 minus tan a tan b. All right? Right. Nice. So we want to derive the double angle formula for tan of 2a. Hold on. Alright, I'm trying to make the thing properly now. Alright? So just bear with me for 2 minutes here, right? Tan of a plus b is equal to tan a plus tan b over 1 minus tan a tan b. Beautiful. So, just as we did in the case of sine 2a and cosine 2a, we're going to express tan 2a as tan of a plus a, which we can get by making b equal to a. So, of course, we say let b equal a. Not looking so like everything else but the word let. Right? So let B is equal to A. So therefore, tan of A plus A is equal to what? Every time we have B, we substitute tan A. Alright? So you get tan A plus tan A over 1 minus tan A by tan A. Alright? And of course, we say now that that is equal to tan A plus tan A would be 2 tan A, and 1 minus tan A. Tan A is the same thing as 1 minus tan squared A. Again, we see a difference of 2 squares here. So, somewhere, somehow, you might want to think of this as 2 tan A over, watch it now, 1 minus tan A into 1 plus tan A. Right now, you could conceivably get this as a question, as an identity in an exam, or something as part of a question where you have to use an identity, right? So they might say, for example, show that tan of 2A is equal to 2 tan A over 1 minus tan A into 1 plus tan A. And if they do that, you could almost be sure that they will only be getting about 2 marks for that. They wouldn't give you more than 2 marks for that. Reason being that to get here, all you need to do is start. Actually, no. You might get about 3 marks. No. Actually, no. No. The reason being, you might get about 3 marks, maybe 4. Reason being, you had to go through everything here. You had to go through this, you had to go through this, you had to go through this, boom, 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 and then you had to come here, right? Which they wouldn't necessarily give you. You had to get to this point on your own. And once you get here, the next step now would be to recognize this as a difference of 2 squares and get that tan of 2A is equal to 2 tan A over 1 minus tan A into 1 plus tan A. Alright? So in these things, always keep your eye open for the difference of 2 squares, because it shows up a lot more frequently than you realize. Right? So, therefore, we can write that tan of 2A is equal to 2 tan A over 1 minus tan squared A. End of discussion. Alright? So, you have the double angle formula for sine of 2A. You have 3 versions of the double angle formula for cosine 2A, and that is something that you need to remember. Right? For cosine 2A, we have 3 versions, all of which you must be familiar with, because you'll have to use all of these things in the course of solving trigonometric identities. And then you have tan 2A, which is just one version there. Alright? So that's basically it, you know. That is basically it. Alright, tan 2A. Alright, make it look more like an A now. Alright, good. So that's it. That is it. So we have derived the double angle formulae for each of the 3 trigonometric ratios, and along the way we would have actually spotted some difference of 2 squares. That is something to keep not too far from your mind when you're doing these things. Alright, so that's the end of this video. As always, we hope that you would have enjoyed it. We trust that you would have learned something. We trust that by seeing the way that I would have worked it, you would understand that this thing is not as hard and as tough and as intimidating as it would first appear. So once you get yourself familiar with these things, excuse, the next step is to go into what I would consider the harder part, which is to use these relationships in unfamiliar questions. You do not pass paper in an exam, you see something that you never see before, and it tells you show that so and so is equal to so and so. Yeah, You now have to figure out which equation to use and how to use it and which form to use it in, etc., etc., etc. That is something that you will only perfect by practice. You're not going to fine-tune that by watching the video. So watching this video is the first step, right? And I want to encourage you, as I always do, to take the following steps. Take the steps that will follow this. All right? Don't just watch the video and stop here. You have to go forward. You have to follow through now with your working and your questions, textbook, past papers, internet, etc., etc., etc. Sometimes you might have to use solutions to get an understanding of the topic, blah, 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 blah. The bottom line is, don't stop here. You have to push on and you have to continue. All right, so keep good, take care, and come back. We have more.